Hello, my name is Richard Kemper, and this is my final screencast for ATM 101 Weather and Climate of Alaska. In this unit, we will investigate the meteorological properties leading to a determination of both the predominant climate at a site in Alaska at a given time and the variability in weather at the given time and place. We will use National Weather Service hourly data and personal weather station data logged in graph form, as well as climate data concerning historic highs and lows recorded by Weather Underground. Finally, we will examine TV weather maps for the weeks in question. We begin with a graph of surface air temperatures as a function of time for the week of April 15th and through April 20th, 2012 in Fairbanks. We see the personal weather station data of daily highs, lows, and early afternoon temperatures shown in red, the National Weather Service data shown as a solid green hourly logging, a solid black line representing average mean temperature, dashed black lines showing average maximum and minimum temperatures, and finally the dashed blue lines representing record highs and lows recorded by Weather Underground. We can see that daily figures are somewhat higher than climate norms, but conditions are fairly stable with no large changes or fluctuations. We might suspect clouds keeping radiational cooling in check, but nothing changing much. The related humidity data of relative humidity and dew point for the week shows a fairly steady but rising trend, culminating in highs for both maximum and minimum on the 19th and sharply falling numbers on the 20th. Relative humidity highs occur each day about 6 a.m. and range from about 80% on the 15th to 92% on the 19th before falling back to 70% on the 20th. Lows occur about 6 p.m. and range from 26% on the 15th to over 40% on the 20th at the somewhat early end of data collection. Dew points range from highs each evening of 29 degrees Fahrenheit on the 15th to 35 degrees Fahrenheit on the 19th, with data collecting ended prior to the high on Friday. The lows vary time-wise, but range from 23 degrees Fahrenheit on the 15th to 28 degrees Fahrenheit on the 19th, dropping to 26 degrees Fahrenheit on Friday the 20th. We have a more variable picture presented by the data for March 4th through March 9th, 2012, as National Weather Service temperatures start out at nearly 20 below zero on the 4th, climbing no more than 15 degrees or so by early afternoon, dropping back to minus 27 degrees Fahrenheit on the morning of the 5th, before climbing dramatically to 12 above by that afternoon. Temperatures have climbed to 25 above by the next afternoon and remain there until a dramatic drop to minus 12 degrees Fahrenheit on Thursday morning. They climb back to nearly 20 above by that evening, but begin a fall to more normal temperatures for the season by Friday night. The station data shows the same basic picture, and the historic figures show a midweek climb to unusually warm temperatures, which may indicate a warm air mass moving through. The humidity data supports our suspicions, with dew point temperatures climbing rapidly midweek to 24 degrees Fahrenheit Wednesday afternoon, falling back to minus 12 degrees Fahrenheit on Friday evening. Relative humidity is less definitive, but shows a trend of low numbers early in the week, reaching very high values midweek, and a general drop later in the week. The weather maps for April 16 and 20 show a fairly warm, low-pressure, unstable air mass, or low front, very slowly traversing the region, bringing precipitation, winds, and scattered cloud cover. There are no dramatic changes in pressure or general conditions, and the weather that week in Fairbanks did not, in fact, show much change over the period in question. The map for March 5th and March 9th show a very different set of conditions. A much faster, better defined, and lower pressure system moves through, followed by colder, more stable, and much higher pressure air behind it. Our suspicions from the National Weather Service data seem to be confirmed. A low-pressure system moved through the interior of Alaska, bringing temporarily warmer, wetter conditions and winds, before moving on and allowing a return of colder, drier, more typically seasonal weather. This concludes not only my screencast, but the classwork for ATM 101 in general. I have found this course to be very challenging from a technology standpoint, but must begrudgingly admit that I learned a great deal and gained confidence in my understanding of weather phenomena and causes. Good luck to all on the final, and have a great summer.